It will have sensors to check the volume of the storage of both the oil and gas, and it will also have all these sensor attached to a browser or a display board. So whenever there is something off, it would trigger an alert or a notification to the supervisor of that particular plant, and the plant individual can either turn off the device, or you can configure a program in a way so that whenever there is an oil leak or a gas leak, immediately shut down the plant by using like it will automatically close all the valves. And if needed, a person with the tablet in his hand, he can quickly check his tablet or phone, turn off a specific valve that is causing a leakage. So this is how it can be, rather than a person going physically locking the wall. It will be all automated that this can be implemented. Another use case for this would be the power grids supply. See, for now, earlier when we were doing electricity lines to home in the city, what happens is they used to cut the wire, then they'll use they'll do all the changes, then they will start the switch, and they'll call the power plant, and they'll ask them to cut the supply, then they'll ask again to turn on the supply. This takes a lot of time. Now it is just simple. Your EB guy will have a phone in his hand. He would just enter the number of the post, then immediately automatically the post would be cut off from supply. And again, he would enter it back on, it'll start to work. So this is one small aspect how digital twin can be implemented on the uh, electricity board, and it is currently working as well. So when I go in more detail about how it can be used across all industry, in terms of manufacturing industry, we have, as I said earlier, we can optimize the production lines. We can sequence how better we can use on the manufacturing process of cars and other things, whether to find whether the quality is defective or not, uh, or whether it is of high standard. Then what sequence should be? Whether should I make car's door first, or the chassis first, or the outer covering first? All these lines can be better assembled in a way using your digital twin by studying and simulating things in your production environment. You can calculate the time rather than physically doing it in a constructed physical building. You can just check whether this production line is correct or not. In terms of healthcare will be very useful. Imagine that you are able to check all your um, health related records, like how much heartbeats you have, what is your calorie intake, wow, if you are having any diseases or not, all this in just a smartphone. And by having a lot of people data, things like COVID or other things could be tracked globally. So when COVID was around, people were checking a site from John Hopkins University. This university collected all the COVID data from each country, and they created a dashboard where it'll be displaying across the world map, saying like how many people got infected, what is the infection rate, what is the death rate, how many people are currently in isolation. So all these data were visible, and this helped a lot of countries to better plan their lockout strategies. And knowing how the disease affects a body. So if it's affecting, for example, a person with COVID is having a less heart rate, or his blood oxygen is less or not. Just by monitoring with sensor, we'll be able to guide a better treatment by helping to suppress all those symptoms in the disease. And when we come to smart cities, as I talked about electricity management, we can do the same for fuel. Think about how transport it would be, transport system would function. Currently, if you have Ola or Uber, you will have a map in your screen that displays your taxi's location. That is nothing but your digital twin. You're able to physically, your physical car's location is present in your digital space, where you know where the car is, whether it's coming to pick up you or not, whether it's going somewhere else, so that you will be able to better manage. With respect to fuel, electricity, water management, you'll be able to better plan how much water is required for the city during this month, how much electricity we have, how much fuel we need to run this factory or other parts of the city. How much fuel should I have it in this petrol bunk or that petrol bunk, based on the readings from just the fuel's volume that we consume every day. All these things would be very useful for city planning. So modern cities are planned in the digital layer now. So they will say, like, if we are planning for 1 million people, these are the things it should be. This is where the housing sector should be. And for this many people, they need this much energy. All these things are first simulated in a digital twin and then implemented. I talked much about aerospace industry, so I'm just leaving that out. So now I'll talk about the implementation part. Okay. So now in the screen, I have a boiler. Okay. A boiler with a humidity sensor of the surroundings. When I say surroundings, it is the humidity of the factory. Then I have the temperature and humidity sensor of the boiler. So this particular temperature humidity sensor is present inside the boiler, so that it would give me the temperature and humidity that is present in of the liquid inside it when it boils. Then I also have a vibration sensor. Okay, so all these three things I'm sending to a place called as MQTT server. So this MQTT server will use a protocol called as MQTT. That is nothing but message queue telemetry transfer. It is used to transfer data as small packets to our digital twin engine. Okay, so all the green lines that we have here in this particular diagram are sending data to the next part. For example, the sensor is sending the data to MQTT. The MQTT is sending the data to digital twin engine. So this digital twin engine, what it does is it'll take the data, it'll store it in the database, or it'll give it to a AI model. If an AI model says that no issues, every instrument is working fine, then it would send the data to the analysis systems, where they will be analyzing this record over a long period. It will be like graphs for monitoring and other things. And it will also send it to a browser where someone will be able to view it in a phone, PC, or tablet. They'll be able to see how the boiler is functioning. Okay. So if someone wants to say, like, no, turn off the boiler, something is wrong, the boiler is vibrating too much, then there is a red line from the microphone or browser. So people can say, turn on the boiler, or people can say, switch it off from the browser. So what happens is this would communicate to the digital twin engine, and digital twin engine would send it to the MQTT protocol, and the MQTT protocol would turn the boiler down. Okay. In case the AI model says something is wrong, you can also trigger an alert to a user's mobile phone. The digital twin will trigger a alert call that would go for user's phone, where the user can say, using their microphone, that turn down the boiler. So immediately the boiler will also get turned down. So the main concept of digital twin relies on the protocol called as the MQTT. Okay. and how it functions. All digital twin does is it takes the data and it structurizes them, it stores them, and it analyzes them using an AI model if needed. So this is the function of the digital twin. The function of the MQTT protocol is to take the data from all the sensors and give it to the digital twin, or take the content from the digital twin and give it to all other actuators. So the reason why we have MQTT is as follows. MQTT protocol is a very lightweight protocol. So if I use a HTTP protocol, what happens is your data that you send to another system, first it needs to be encrypted, and then what happens is it needs to be validated by both the end. So it takes so much time and processing. So when I talk about 5,000 sensors per second, it needs a lot more processing capacity to process it. But whereas if you go for MQTT, this particular client and server is validated only once during a handshake, and the handshake is retained throughout the system's lifetime. Whereas in HTTP, it is for every request. Every request, the client and server is validated. In MQTT, it is not that way. Only during a subscribe part or a publish part, there will be a validation. And whenever this data gets transferred, there will be no validation. So the protocol is very lightweight. Here, publish subscribe model involves like a sensor would publish the value. A client is like a digital twin or a monitor or a laptop or any other devices, any other computer or servers would subscribe from the MQTT broker. When I say subscribe, it will get the data. Publish would send the data. Okay. So when someone published the value to the MQTT broker, that particular publish would be sent to all the subscribers who are subscribed that particular sensor. Like let's say like temperature sensor is sending value. Whoever wanted this particular value will be able to get that particular value by subscribing to the MQTT broker with the ID of the temperature sensor. Okay. So this is how publish subscribe works. Since the temperature sensor is not directly connected to any of the end result systems, the resulting format of communication is asynchronous. Synchronous means both are moving together, or both are at the needs to be present at the same time. Asynchronous means whenever one is ready, it will get the value and it can process it. So asynchronous is very much essential when we go for scalable systems, because we don't have systems ready for every single time. And scalability, as I said earlier, it is very much suited for larger systems, MQTT. In fact, these days, they are using MQTT to balance servers. To connect multiple microservices, they are using MQTT. Because MQTT, as I said earlier, message queue, telemetry transfer, where message queue is nothing but messages in a queue. Where T stands for telemetry, that is nothing but data. Transfer is just transporting the data. So since it is a queue, this queue is so effective that they want to store APIs in it and load balance using this particular broker itself. Then we come to the last segment of MQTT, which is called as the last will and testament. So last will means we all know what is a will. The last wish before a person dies. So this is called as last will. So what census last would be like? If my this sensor is not working, tell that if I'm not saying anything for the next 10 minutes, consider that my the sensor is not working, and say the temperature is 100, or temperature is 0, or temperature is 50. So that if some sensor is faulty, we would know, and if it's not sending information, all these subscribers would know that this sensor is not working. because it is supposed to send information in 5 to 10 minutes. Okay, that's how last will and testament work in MQTT program. So this is a configuration will configure in the topic, which is nothing but your sensor ID. So in the future, this particular technology would be used on lot many things. So we all talk about AI and machine learning, correct? And robotics. Think about a complete plant operated fully by robots, and that requires all these digital twins to process and get the thing, get implementation done. And think about the agriculture industry, having an edge computer in a farmland and monitoring the entire entire crops, field, and other things, and using automated sprinklers monitored by using a digital twin would reduce the cost of labor a lot. So in India, we are still having farming used by physical labor. But if you go to European countries and US, it is mostly machines. And we talk about hydroponic farming and other things where having temperature values, water level, and other things are very important, so that you can just monitor your entire facility at any part of time with less labor cost. So edge computing and digital twin would reduce your cost of your initial computer, and you can able to connect to cloud directly, and from cloud you can connect to your home or your office or whatever it is. Okay, and think about the industry as an example. Earlier, before the age of colonization, before like when they found the steam power, we then when people found the steam engine, there was a huge wave in industry, because you'll be able to make mechanical parts, you'll be able to make mechanical looms, trains, or companies which could manufacture stuff using just the steam power, like nails, spanners, or any mechanical equipments. So this was industry 1.0. In industry 2.0, it's about the assembly line and mass production. Using electricity, they'll conduct electricity to the industry, and they'll continuously manufacture parts 24/7. The current age we are there in is industry 3.0, where we are all the things are automated and computers and electronics are controlling it. Like if you take the chip manufacturer or the car manufacturer power plant, yes, are all industry 3.0. But in industry 4.0, we would be using Internet of Things network, that is IoT, and we'll be using digital twins to create a physical systems replica in a digital layer. So an entire office can be monitored in just a single application, like a phone or a tablet. So any questions? If you have any questions, feel free to type it in your Gmail chat. I can read it and respond.
Good morning, sir.
Good morning.
Sir,
Yes.
sir, in the industry 4.1, first topic, cyber physical systems. Explain, please, sir.
Cyber physical systems. So Cyber is nothing but a different word for your digital or your cloud related systems. That is cyber reality, they will used to say. That is not just another word for digital. So physical systems I have talked about stuff. And it's the system that is actually existing in your physical environment. So when we talk about cyber real physical system, it's nothing but a digital version of a physical system. So let's take an example of Oculus or HoloLenses, where people used to wear something on their head, where there will be a display and they will be present inside the field directly. For example, if you're wearing an Oculus, you can directly go into your industry or your agricultural field or anything and look at things how they actually exist in the physical world. For example, let's take like you are working from home and suddenly there's an alert inside the your factory that they're saying that there's a fire. So people cannot go in and check what fire, what is the source of fire, correct? But you also have cameras that are analyzing your factory. So what you can do is you can wear these headsets and you can go and check where the fire started, which part the temperature is high, using a VR headset and other things. So all these concept comes into the cyber real physical systems, which is nothing but implementation of a digital twin over a physical system. So okay, future enhancement in agriculture IoT. So agriculture IoT is a big area that most of the big countries are focusing on. So right from devices that could study the understanding of leaves pattern. So whenever a crop gets infected, mostly the leaves or stem, it gets affected. They're talking about implementing drones which can scan all these your agricultural field. It'll be there for acres and hectares, right? All these area, it will take quick images and will analyze using image recognition technology. It will say which pesticide you need, or it will also see whether it's the time for whether it is the time for the harvest or not. When there would be more flowers. Okay. So now there are other scenarios in which other countries are being affected. For example, for pollination, people don't have enough insects or bees because of the pesticides. Now they need to manually pollinate. So some people are bringing bees from other districts to pollinate their flowers and other things so that they will get fruits. And in hydroponic systems, they're just manually pollinating when it started. So you need some amount of physical work to be done when flowers are present. So I need to track what are the flowers that are pollinated or not. So for all these things, it is good to check it in a digital format so that you'll know whether this flower is pollinated by a person or not, by which person, etc. Okay, I'll share it to Deepa ma'am, the PPT. In India, agricultural IoT is implemented in many states, but not the digital twin. So IoT is nothing but it gives you the value. When you say digital twin, it has the mirroring aspect into it. So for example, if the sensor says there's no water in the land, it is IoT. But if I am able to give water to the land from some other place, using controlling my pipes and sprinklers, then it becomes digital twin. Okay, that is the major difference. Okay, what are the benefits? Benefits of digital twin technology, as I said earlier, it's gonna improve your efficiency, how you work with your industry, or any other system. So, for example, I'm just saying in a college, if I'm implementing digital twin technology, I'll be able to get a person's information, uh, whatever information they want, in my app whenever I scan their face. So I'll be knowing their mark sheet. I'll be knowing what assignments they have completed, what are the things they have implemented, how far did they complete in their laboratory, what is their current status of their final year project. Hmm? What are the remarks they have, what are the black marks they have, every other thing, what are the events they participated, how good they are in sports. So all these things can be tracked in one single location, and this gets activated just by like scanning their name or the ID card, or they're taking a photo of them. Okay. So, Nandu Karthi, digital twins can support any type of applications. To be, in fact, if you guys could ask me like how to implement a digital twin technology over an application, I can respond to it. Generally, we have sensors now for most of the things. So, and if there is no sensors for it, we still can create some other set of things to control it. Like for example, we have Bluetooth communication, Wi-Fi communication. So earlier we only had mechanical switch for fans. Now people are talking about remotes, Wi-Fi, and other things. So adding a digital twin to an existing technology or an existing physical product is not a big hurdle, but whatever it is, we can still add it. But the cost implication, whether you need it for that cost or not, that's the thing. For example, I wouldn't spend uh, a cost of 2,000 rupees to have a Wi-Fi operated fan. Okay. Rather than that, I can have it on my power grid, so that I can control the entire power supply of my home. I can turn down the fuse whenever I want to. So it's like the cost implication, other things. If you want it, you can have it, but just check the cost benefit of it. Like, I'll make sure that I'll share it to Deepa ma'am, the PPT. Any other questions?
I will send it to group, Hari.
Okay, ma'am. Any questions? So one thing I would like to add here is, so this particular seminar is mostly theoretical, but digital twins can be understood in a better way if we try to do it practically. So as I said, there are some boards, they call it ESP32 boards, which cost around like 200 to 500. We can have it, we can attach the sensors in your laboratory. We can check how it would be useful. For example, to know the temperature of your classroom, you can have your thermistor attached to a ESP board. Then that can communicate to your mobile phone over Wi-Fi, and then you can see what is the value of your classroom. And based on that, you can again create a switch to turn on your air conditioner or your fan, or send an alert to the system. So many things we can do, and it's so much good to interact and work on. So it is not just software, and it's not just electrical. On most cases, it is more about solving the use case. For example, how to implement it over your laboratory for safety guidelines, and to check whether the people are properly handling the equipments or not, whether there's a leakage in apparatus or not. So many things can be done. Or you can even check the power supply of your entire college, provide a report on whether people are turning off their fan light on off hours or not, whether something else is running in your classroom after everyone left. So all these details can be easily figured out and generated by simple circuits and softwares.
Oh, okay, Hari, shall we wind up
Yeah,
with
if,
vote of thanks?
yeah, sure.
Thank you, sir. I welcome Mr. M. Ganesh Kumar, sir, Assistant Professor of Computer Science, to propose the vote of thanks.
Happy morning to all. I am very happy to say thank you to all. Then I express my heartily thanks to our today chief guest Hari Praveen for accepting our invitation and being here. Thank you, sir. Next, I thank our department HOD, Mrs. Deebalakshmi, and our department staff members for always supporting and guiding us. Then last but not least, I thank you all the participants from various colleges. Thank you.
Thank you all.
Thanks, team. Thanks for your time.
Hari, it was nice session, Hari.
Thanks, ma'am.
Thank you so much for your wonderful presentation.
Thanks, ma'am. And thanks, students and professors.